Welcome back to KSET previous year question and solution classes. Today I will discuss classical mechanics 2014 year, so physical science part. So here constraints that can be expressed in terms of a equation relating to coordinate system. So the constraints, that means which is restricted for a body in a particular direction. Okay, so if the question they are given, it is possible to write in terms of an equation relating to the coordinates and time. Okay, so your time is did not mention, but equation is given to identify the answer. So in the question, if we can see that it is possible to write in terms of an equation, so then it is holonomic. Okay, so in non-holonomic means, so it is not possible to write in terms of a equation. So that is non-holonomic. Actually, here in the question it is possible to write in terms of equation. In other is clearonomic and rheonomic. It depends on time, and one is not independent of time. Okay. So, but here the answer is holonomics. Next question is, the Lagrangian is a function of, the Lagrangian is a function of qk dot, qk comma pk dot, and qk comma qk dot, and qk comma pk, and p dot k comma p dot small p dot. Okay, so here the Lagrangian is a function of qk dot qk. So this is an answer. Why? Because we know that Lagrangian L is equal to, it's a function of L is L of q comma qk dot comma t. If you write the equation of motion in terms of a Lagrangian, we know that dou L by dou qk dot d by dt minus dou L by dou q is equal to 0. So therefore the Lagrangian is depend on qk dot and q. Okay, so answer is B. Next, the repulsive inverse square force than the shape of the orbit is. That means if there is a particle and if another particle is which is revolving in the around the nucleus, or you can consider any body at the center and the other body is revolving. Okay, so here in the question they clearly mentioned it's a repulsive force, repulsive inverse force. That means F is inversely proportional to 1 by r square. So therefore it is, and also inversely proportional and repulsive. We know that if the center there is a sun, the planets revolve around the sun with an elliptical orbit. So the force between the planets and sun is attractive, right? So if the force between the two bodies is attractive, so then it is elliptical. It is elliptical. If the force between the two bodies is repulsive, so then it is hyperbolic. Why? Because, so the best example for this reaction is, if there is in the center there is a nucleus. Let us consider another alpha particle, a positively charged alpha particle. Here it is also positively charged nucleus. When the positive charged alpha particles comes very close to the nucleus, it gets repulsive. So it forms a hyperbolic form. Okay. So therefore answer is hyperbolic. If the force is repulsive, and then it forms a hyperbolic shape. And if the force is attractive, then it forms elliptical. Okay. Next question. Kepler's second law states that aerial velocity is 0 and aerial velocity is constant. Angular momentum is not constant. Linear velocity is constant. Kepler's second law states that aerial velocity is constant. So option B is correct. So from these four options we can easily guess that aerial velocity is is 0. No, it is not possible because aerial velocity of a particle never be 0. Next, angular momentum is not constant. No, angular momentum is not constant. So this is also not correct option. And linear velocity is constant. No, it is not possible. Linear velocity definitely is not possible to constant during circular motion. Option B is correct. Next, in the Hamiltonian formalism, H is equal to summation k pk qk dot minus L. H is equal to summation k pk qk minus L, and L is equal to summation k pk qk plus H, and L is equal to summation k pk qk plus H. The Hamiltonian formalism. So the Hamiltonian formalism is H is equal to summation k pk qk dot minus L. So option A is correct. Next, Hamilton's principal function S and Hamilton characteristic function W for conservative system are related as. Answer is S is equal to W minus ET. Option D is correct. Next, the Lagrangian for a particle of charge E in an electromagnetic field is given by. We know that the Lagrangian L is equal to T minus V, and V is the potential energy for electromagnetic wave. We know that E phi minus V into Q, or nothing, if it is Q, it is also Q into V dot A. Okay. So here in terms of a CGS system, we can divide with C. So therefore L is equal to T is kinetic energy. Therefore T minus what is potential energy minus Q phi minus, because it is here it is plus, so minus into plus is minus. If it is E phi, and minus into minus plus E into V dot A by C. So A dot V by C, which one is correct? See, from this question, from this option A is correct. T minus E phi plus E by C AB. So next question is from part 3 of 2014. So if the Lagrangian does not depend on time explicitly, then the kinetic energy is a constant of motion, the potential energy is a constant of motion, the Hamiltonian is a constant of motion, the Hamiltonian cannot be constant of motion. So if the Lagrangian does not depend on time, okay, so that means if suppose it does not depend on time, means dou L by minus dou L by dou T is equal to dou H by dou T, which is equal to 0. So then if dou L by dou T is equal to 0, then dou H by dou T is also 0. That means Hamiltonian is also constant of motion. So Hamiltonian is a constant of motion. Option C is correct. Next, for a given transformation, T1 is equal to Q is equal to P, and P is equal to minus Q, and T2 is equal to QP, P is equal to Q, where P and Q are canonically conjugate variables, which of the following statement is true? Both T1 and T2 are canonical, only T1 is canonical, only T2 is canonical, and neither T1 or not T2 is canonical. So let's verify this. See, this is T1, Q is equal to capital small p, and capital P is equal to small q. The relation, if dou q by dou q and dou capital Q by dou small p and dou capital P by dou small q and dou capital P by dou small p is not equal to 1, then it is not canonical. If it is equal to 1, it is canonical. Okay. So let's see, it is 0 because dou q with respect to small q, is there any small q term here? No. So that's why it is 0. And dou q by dou p. So with respect to small p, we will just differentiate this one, and here it is small p. So the differentiation of p with respect to p is 1. So it is 1. Next, dou p by dou q. So p term is this one. With respect to q, if we differentiate, it is minus 1, right? Because minus 1 is there. And also with respect to p differentiate this, it is 0. So 0 minus of minus 1 is equal to 0 plus 1. So plus 1. So it is equal to 1. Okay. If this Jacobi transformation is equal to 1, it is canonical. Okay. So now therefore T1 is canonical. Let's try it for Q2. So Q is equal to small p. Differentiate this p with respect to Q. There is no Q term, so it is 0. And differentiate with respect to p, it is plus p, so plus 1. Okay. And differentiate this term with respect to small q is there 1. And this, okay, 0. So which is equal to 0. 0 minus 1 is minus 1. So it is not canonical. So T2 is not canonical, T1 is only canonical. So the function only T1 is canonical is the answer. Next question. The Poisson bracket of any constant of motion with Hamiltonian H is 1, minus 1, 0, infinity. See, the constant of motion is mentioned in the question, so then we can easily guess the answer is H. Then only we can say the Poisson bracket is equal to constant of motion if any function p comma h is equal to 0. That means Hamiltonian is a constant of motion. Next question. The principle of least action in terms of arc length of the particle trajectory is. So we can easily guess from these 4 options. We know that the total energy E is equal to kinetic energy plus potential energy. So E is equal to kinetic energy means of mv square plus v. So then of mv square is nothing but E minus v. So therefore, and also see, in the option, if you consider v, it has some coefficient into root of E minus v. Okay. So forget about this. In the option, is there any function? H is nothing but total energy. Know that H is equal to E. And is in the option, is there any H minus V term like this E minus V? In the option, is there any H minus V term? So let's see. This is H plus V, this is H minus T, and this is H plus T, and this is H minus V. So in the option D, we can see that H minus V, and this is H plus V. It is not conservative. In the if there any equation like H minus V, it is conservative. So then we can see, we can easily guess option D is correct. It is in the form of total energy E minus V. Okay. So option D is correct. If you simplify this equation, again we will get this one only, but no need to calculate at all. So actually in the part A paper, I forgot to discuss to the 16 and 17 question numbers. So I will discuss now here itself. So the length of the space vehicle is 100 meter. So L is 100 meter, and on the ground when it is in flight. Okay, when it is in the ground, the vehicle length is 100 meter. When it is started flying, okay, so like this, when it is leaving the earth, so it is flying, so its length is observed on the ground. The person in the ground, seeing this vehicle, he can see its length is 99 meter. Okay, so I am considering this is L0, actual length of the vehicle, and the length contradiction from the person, he is seeing, I am considering that as L. For him it is 99 meter. So now we are discussing the speed of the vehicle in the space. So now what is the speed of the vehicle in the space itself we should see. Okay. So the expression for this is L is equal to L0 by gamma. So what is gamma? Gamma is 1 divided by 1 minus V square by C square, square root of 1 minus v square by c square. Okay, so therefore L is equal to L naught divided by 1 minus v square by c square root, and L naught is actual length, that is 100 meter. Okay, divided by what is this one, root of 1 minus v square by c square, which is equal to, for the person it looks like 99 meter. Then by cross multiplication we will take 100 divided by 99 is equal to, okay, so root of 1 minus v square by c square. Let us take a square root. So 199, when if it send the square root to this side, it will become square. So 1 minus v square by c square. Okay, so after simplifying this we will get, so 100 by 99 whole square, which is equal to c square minus v square by c square. So 99 ones are 99, so 1 point, and again if it will become 100 and 1.1 something, 1.1 square is equal to c square minus v square by c square. So 1.1 into 1.1, we know that 1, so 2, okay, so 1.21 c square, which is equal to c square minus v square. So 1.21 c square minus c square is equal to v square, and if you take c square, 1.21 minus 1 is equal to v square, and v square is equal to 0.21 into c square. V is equal to square root of 0.21 into c. So v is equal to square root of 0.21 into 3 into 10 to the power of 8. So after solving this, we will get v is equal to 42.2 into 10 to the power of 6 meter. Okay, so option B is correct. Next, question number 17.1. A rigid body moving freely in space has degrees of freedom. So for this rigid body, there is no any constraint, so it is freely moving. So a rigid body moving in a free space has 6 degrees of freedom. It has 6 degrees of freedom.